Hello guys, and welcome back to Engineering Hack, where we try to solve engineering problems with the assistance of ChatGPT. So we just solved the problem on the nozzle. It's published last week. You can check it out here somewhere on the corner. And I thought I would give ChatGPT another try, see what's going to happen this time. And basically here's the problem. I asked it to solve and gave it the problem statement. And it starts very well. It talks about, conservation of mass and energy. That's exactly what we're going to be using. Conservation of mass applies, so you can say continuity equation applies, so that mass flow rate of 0.01 is going to be the same on both. That is true as well. Mass of ammonia into the nozzle, leaving the nozzle, we can apply conservation of energy. So therefore, the enthalpy and the kinetic energy of one side has to be equal to the enthalpy and the kinetic energy of the other side. So far so good. It's great. The analysis is amazing, like how to solve this problem. The properties of ammonia and the inlet conditions can be determined in the steam tables. That is right too. And other thermodynamic properties softwares. The ammonia is at 803 kilopascals. That is right. And we find that the enthalpy is 1446. And I think that's already off, isn't it? 1446. It might be already off from what we were when we did the analysis. No, so we got 1461, so it's not spot on, but maybe a different source. So I wouldn't say this is gonna make much of a difference yet anyways. It's a deviation from what we were using, the tables we've used and all, but it's not a big red flag here anyways. At the outlet conditions, the velocity, that's correct. The ammonia is a saturated mixture, so we don't know that yet. It cannot know this yet. So this is something that is a red flag. The software saying, the AI saying that this is a mixture is not something that we can know just yet. And then we can use equality to find it. So if this were true, this would be true. Second sentence would be true. To determine the quality, we can find using the following equation. So it's relating just, this is not true, to, well, yeah, okay, so we'll see what you're saying. That's all right. It's right. From the steam tables, we find that the HF is 293, and the saturated vapor one is 1,000. So this is completely off, right? When it gets to this point, it's completely off because it is basing this. I'm not sure what is basing it off because for this value here, we know that the HF is 135-ish, and the HG is 1433. So I'm not sure what's going on here, but it's completely different from the steam tables we've been using. Maybe it's looking at a different, well, it says ammonia here, so I'm really not sure how it's getting these values. But anyways, here's completely off, and then it's going to say there's that density that is right, so that's the density for the fluid. And then for the nozzle, you can use a mass flow rate, density, and velocity that is right too. It starts substituting values, and then it creates simultaneous equations for the area, cross-sectional area, and for the enthalpy. And it calculates both, and they're both incorrect, right? So both the area and the enthalpy too is incorrect. So it stops halfway, so continue. It says the temperature of the mixture. To calculate the temperature of the mixture, it's going to use the quality that's already found. So yeah, so it finds a different quality, by the way. So here it finds 54.4, and then it finds 54.1. So I'm not sure what's going on. And it uses iteration to be able to find the temperature. So it ends up with the conclusion that the temperature is 26.5 degrees Celsius, which is impossible, right? We were originally at 18 when we started this problem, and we know we used the internal energy to transform that into kinetic energy. So here it's saying that the software just concluded that we created energy somehow because we went from 18 to 26.5 and from a negligible kinetic energy to 450 meters per second. And note that there's, these conclusions and these answers, the ones that are off, but everything else is right. So it's super easy for someone who doesn't know what's going on to get confused and to just trust this. So I say, this is incorrect. And it tries again. And again, a lot of convincing arguments here on how to calculate things. And it starts off really well, but then it starts to go south at some point. And again, gets wrong answers at the end of it. Because the whole point here is that you need to calculate enthalpy 2, right, of the outlet to be able to grab the properties. And it doesn't do that. It bases the outlet properties maybe on the density of the fluid. I'm not sure what's happening here. And then it comes to the conclusion that the enthalpy, the quality is not the 54% it had before, but rather 43%. And it comes to the conclusion that the temperature is 13.8. Again, now this is better, right? Because now we went from 18 to 13.8. So it's not thermodynamically impossible, but because it didn't calculate the enthalpy properly, then it is incorrect, right? And then, its final sentence here, note that the solution assumes a nozzle is adiabatic, which is correct, meaning that there's no heat transfer between the ammonia and the surroundings. It also assumes that the flow through the nozzle is isentropic, meaning there's no change in entropy during this process. There is a reasonable assumption since the flow rate through the nozzle is adiabatic and there's no significant heat transfer. So everything here is right? So all the, the sentences, all of that is spot on. The problem really is the some specific points that makes the whole thing be incorrect. But then I tried something else. What I said is, I said, please solve this. Let me go back here. Please solve this and note that the answer is minus 10 Celsius and the area is 8.77 times 10 to the minus 6 meters squared. So here, and this is probably scarier from my perspective as a lecturer, as a teacher, as a professor on the subject, it goes with all those right, sentences, mass conservation, etc. It uses Bernoulli equation here for whatever reason, which is not wrong. It's somewhat wrong, and it goes about solving it. But the trippy part here is that it takes a very weird path with some very incorrect numbers, such as the enthalpy 2 being 40 when we've calculated it to be 1300 or so. And it gets the quality at 41 when we know it's 94%. Check the video to remind yourself. But the thing that, and they say continue instead of continue, but it understands me and it goes on. But then the very scary thing is that it comes to the conclusion that the area is exactly what I said it should be, and that the temperature is minus 10, as I said it should be too. And that's very, very worrying because, if you're a student and you just put down there, solve this for me, this is the answer, you're going to get the final answer you're looking for. And you're going to get a lot of right sentences in between, but the method itself, the solving, is incorrect. Either because somewhere along the way it chose to use a method that doesn't apply because the situation doesn't allow you to do something, or because you simply got a wrong number along the way and that wrong number just carries on and makes everything else incorrect. But that's super, super worrying that you can just put, solve this with this answer and it gives you the right answer. And if you're a student and you trust this, you're not going to learn, and you're going to, obviously if you submit this is very bad, but you're not going to learn, and if you trust this, you're going to be getting wrong information or wrong advice or wrong lessons on this. And then it's so much harder for you to go back and understand what's going on and try to, rewire your brain to be able to think properly to solve these problems. So, word of advice, like on the last video that I did on ChatGPT, is this is amazing. This is great. You should try to use it. But you need to be very careful, right? It's not ready yet to be able to solve these problems. So don't rely on it for this kind of thing. All right. So I hope this was useful. If it was, consider giving this video a like. If you have any questions, just leave them down below in the comment section and we'll talk soon.